9-2 reciprocal function family part 2. All right, guys. So I've already done this once. You don't know that, but that's okay. You do now. But I went over my time limit, so I'm going to be more concise. Good things, right? All right. Okay. So we are looking at the translations of the reciprocal functions, meaning that we're shifting them left and right, up, down, all that good stuff. All right. Now, in your textbook, they provide these really cool examples where they're showing you the translation, whether it be up and down, left or right. So definitely, to save time, you guys look at that. The red one is going to be the parent function in both cases, and then they give you two different functions, one going right and left and one going up and down, and what the differences are there. Okay, looking at the summary box, this is something we need to hit. The parent function is y equals 1 over x. That means nothing is being done to it. It's not being shrunk, it's not being stretched, it's not being moved right, left, up, down, reflected across the x-axis. It is by itself, pure. Right. Now, in the previous lesson, I wasn't as clear as I could have and or should have been. And I had said that if your A is greater than 1, that's a stretch, and that means that you are basically treating it like a rubber band, pulling it, and it gets taller and thinner. And then if it's less than 1, I should have said if it was between 0 and 1, then it is a shrink, and that's the same as if you're taking the rubber band, especially that one that comes with the game operation because it's more sturdy. When you squeeze it, it widens out, it becomes shorter, right? Now, the reason that I should have said between 0 and 1 is because less than 1 could include negative numbers. Well, if it's negative, it's going to go across the x-axis, it flips. The parent function is in quadrants 1 and 3, but if you reflect it, you have a negative a, then it goes to quadrants 2 and 4. And then finally, the general combined form, the translation going right and left or up and down. This is consistent with what we have seen with the absolute value, with the quadratics, with the square roots, every different type of function that we've done so far. So when you have the minus h with the x, then that's your right and left movement, and it goes opposite of what you think. The plus k, that is separate from the x term, tells you to go up or down, and it follows with whatever that sign is. So positive, up, negative, down. All right, let's go ahead and take a look at these examples. All right, so our first example for today, example 4, is graphing the translation. So to sketch the graph of this given textbook example, we have y equals 1 over x minus 2 and then minus 3. Well, the number in the denominator is going to be your right and left movement. And in this case, you have x minus 2, so you go opposite of what you want to think, so you go 2 units to the right. And I would go ahead and plot that and sketch that out. And then you have minus 3, so that tells you you're going to go down 3 units. And again, do that right away. So now you have your asymptotes, okay? At this point, go ahead and find out what your coordinates would be for the parent function, and then you're going to translate. Shift that right, left, however many units, up, down, however many units. And you could plug those numbers in if you wanted to. Students have done that successfully, but you just have to remember that your asymptote has gone 2 units to the right, so you need to pick x values to the left of this vertical asymptote, and you need to pick values to the right of that vertical asymptote, and then that's going to help you get your branches drawn out of this hyperbola. All right, so now let's take a look at the example for your notes. We have sketched the graph of y equals 1 over x plus 2 and then plus 2 separately. So this plus 2 in the denominator tells you to go 2 to the left, and this 2 up here tells you to go 2 up. So now let's go ahead and sketch, and I'm going to apologize again because I'm doing this on the wireless slate, not tablet. And I'm doing it just by faith. So, and y'all know that I have a hard time doing it on the smartboard when I'm standing right in front of it, so this makes it 10 times as challenging. All right, so as I finish this, I want to again draw your attention to our asymptotes that we're going to be placing. And this is 2 to the left, so we're going to go 1, 2, put a point 2 to the left, and now draw your dashed line to represent your vertical asymptote. And then 2 up, so you go up 2 and draw the dashed line through this vertical asymptote, through that point to create your horizontal asymptote. Sorry. Okay, so now we are going to find coordinates for the parent function, y equals 1 over x. And what's great about this is once you do this a few times, then you have the numbers memorized and you don't have to really worry so much about what you're doing. So I'm going to go with -3, -1, and -1/2. This one I'm going to do 1/2, 1, and 3, just to kind of get a broader picture of what's going on. Okay, so now plugging those in. 1 over -3, so -1/3. 1 over -1 is -1. 1 over -1/2 is -2. 1 over 1/2 is just 2. 1 over 1 is 1, and 1 over 3 is 1/3. All right, so now let's go ahead and plot the parent function points that we have. All right, so we have -3, -1/3, -1, -1, -1, -1/2, -2. Now remember, I'm not going to sketch this because this is the parent function. And then we have 1/2, 2, 1, 1, and then 3, 1/3. Okay, so now I need to shift these points, translate this. I've got to go 2 to the left, 1, 2, and then up 2, 1, 2. We're going to go 2 to the left, 1, 2, and then up 2. 2 to the left, and then 2, up 2. So now these are those points, right? Oh, sorry. Like I said, trying to do it blindly. Not too shabby. All right, 2 to the left, 1, 2, and then up 2. We have 2 to the left, and then up 2. 2 to the left, and then up 2. And here is our second branch of this reciprocal. Okay, all right, so now that's one way of doing it. The other way that you could do it is once we have, and I'm going to change that color even, once we have gone and done the asymptotes, that's obviously going through -2. So you can pick numbers. I would go with 2 or 3, preferably 3, just because it makes your life easier. I would go with -3, -4, and -5. So -3, -4, and -5. And then you can also go with -1, 0, 1. So now plug that into the original equation that you have, the y equals 1 over x plus 2, evaluate it. So 1 over -3 plus 2 is going to give you -1. -1 plus 2 is 1. -4 plus 2 is -2. -1/2 plus 2 would give you 1.5. -5 plus 2 is -3. -1/3 plus 2 is going to give you 1.7. Did I do that one right? Yes. Okay. And then -1 plus 2 is 1. 1 over 1 is 1. 1 plus 2 is 3. 0 plus 2 is 2. 1/2 plus 2 would be 2.5. 1 plus 2 is 3. 1/3 plus 2 would be 2.3. And so then you would plot those points. So 1, 2, 3. -3, 1. -4, 1.5. -5, 1.7. Oh, stop it. -1, 3. 0, 2.5, and then 1, 2.3. All right, so again, two different ways of doing it. Both are valid. Both are good. I don't really know which way you would prefer. I'm good with either one. Okay. All right, final example that we have is now writing an equation given the transformation. So in the textbook example, it says write an equation for the translation of y equals 5 over x. So that is our parent function. So that means we are going to do y over, not y over, sorry, y equals 5 over x minus h plus k. Now they give us that x is -2 and y is 3, so you have to plug in -2 here and 3 here. Minus and negative makes that positive, so then you have y equals 5 over x plus 2 and then plus 3. And that would be your equation. Okay? All right, now this suggested example from the author says compare the graphs of y equals 2 over x and y equals -2 over x. Your answer for this would be that the 2 over x would be your quote-unquote parent function, and -2 over x would be your translation. And that was a reflection over the x-axis. So where y equals 2 over x has branches in the first and third quadrants, y equals -2x, 2 over x has branches in the second and fourth quadrant. So you would use that sort of language, right? All right, now let's go ahead and move on and do this final example. Write an equation for the translation of y equals -1 over x. So the parent function in this case is -1 over, and then you have x minus h plus k. So now we need to determine what is my h, what is my k. This says 4 units to the left, right? So I'm going 4 units left, which means that's x is negative, well, yeah, x is -4. And then 5 units up means that we have y is 5. So my values are going to go -4 in for the h, and then the 5 is going to go in for k. Right, so let's write that out. We have y equals -1 in the numerator because that's the parent function. That's what we were given. We have x minus a -4, and then plus the y in this case, that k is going to be 5. Minus a negative makes that positive. We do not, ouch, sorry, the cat got my foot. We do not leave the answer with 2 pluses because that is not in simplest form. So then we have y equals -1 over x plus 4 and then plus 5. Whew, y'all, this cat. Okay, so that is it for 9-2 day 2. Hopefully that made sense, and I apologize for the slight interruption there a second ago. Okay, if you have any questions, please holler, let me know. You know how to find me.